Hello, I'm Stuart. I'm a Ministry of Defence Chief Engineer for the Submarine Disposal Programme.
My name is Barry Rice. I work for Sheffield Forge Masters as Head of Sales.
I need to prepare laid-up submarines for the defuel process. Part of that is removing a significant amount of high-grade steel, which we are now shipping to Sheffield Forge Masters for them to recycle into the future submarine fleet.
So it makes perfect sense for Sheffield Forge Masters to take this steel. Because it's there, it needs to be used, and we can make significant savings on sort of buying this on the open market.
If I was to explain a step-by-step process of how the submarine steel is recycled, it first comes off the submarine in one of our dockyards. It's removed and shipped to Sheffield Forge Masters, where it is then melted down and forged or cast into new components which go into the future submarine fleet.
We receive naval grade steel from the hulls of these recycled sort of submarines. That steel is the right grade for us to use as scrap into our sort of our melt shop process. We take that scrap material and we put it into our melt shop. That will get melted. It comes out in typically 100 tons at a time into an ingot mould. That ingot mould then gets forged, so it goes into our forging process. Forged, heat treated, machined, and then tested.
So submarine steel is a specific grade, and what I mean by that is that it's a specific chemistry and then goes through a heat treatment cycle to deliver the desired mechanical properties that specific component needs for those harsh environments. So looking at naval grade steel and non-naval grade steel, with the naked eye, no, you wouldn't be able to tell the difference. However, if you were to mechanically test that steel or look at it under a microscope, then yeah, you'd see quite a big difference. If you were to use ordinary steel, that probably wouldn't be able to withstand the pressures that submarines are subjected to, opposed to the naval steel that we're producing. We ensure that the recycled steel maintains its properties by melting the steel and casting it into an ingot. That ingot is a specific grade of steel, so it has a specified chemical composition. And then from that we can apply a heat treatment to ensure that it meets the desired mechanical properties that the customer wants. So at Sheffield Forge Masters we operate an electric arc furnace. So it's a 35 megawatt furnace, and with that we melt 100% scrap. From that the steel is tapped into a ladle. We have ladles of ranging from 100 ton down to 50 ton. And then we have two secondary steel making units, so a VAD, vacuum arc degasser, and a ladle furnace, which is basically just a holding furnace. And then we have two different casting methods, so vacuum stream degassed ingots, and then also uphill teamed ingots as well. So when we melt the naval steel, it's charged to our electric arc furnace, and then we use 3 graphite electrodes, which create an arc between the electrode and the steel. And it's the sort of temperature of that actual arc that melts the steel.
So this ladle in the VAD, vacuum arc degasser, has just finished its degas. So in a moment the VAD roof will come off and the operator will sample the steel. So we're sampling for chemistry, temperature and oxygen content throughout the process.
So in the forge, we preheat ingots to a specified temperature, forging temperature. They are then moved by a crane onto the forging press, which is 10,000 ton, and then they are forged into the desired shape. I'd say the most technically challenging part of the melting process or steel making is meeting the customer's chemical demands. So often on defence and naval grades, they are quite low residual, so really clean steel. And so ensuring that we meet that chemistry is quite technically challenging. In terms of scientific disciplines, we have a team of metallurgists in each department. They're supported by our research and technology teams. As they've also got engineering and maintenance teams who ensure that the plant is fit for purpose and working as well.
So the research and development department, when they're looking into sort of how these steels perform, use science and innovation to make sure that they collaboratively work together with other departments in the forge and the melt shop to make sure that that product is what we need and the best it can be.
One of the most interesting things I've learnt about Submarine Steel is the partnership between the Submarine Delivery Agency and Sheffield Forge Masters, and the art that goes into turning that steel around back into the new submarine fleet, whether it's the chemical composition or the metallurgy or the quality assurance and the high standards that need to be achieved. It's been really interesting to see the melt shop and the forge and just the scale of the engineering being undertaken here. It's certainly opened my eyes and shown me how it's more than just engineering, it's also an art form. And I'm going to take that back to my team, and we're going to work hard to keep supplying steel to Sheffield.
I think it's amazing that the steel we produce ends up in submarines. You know that you're producing steel for such an important application, so that fills, I think, everyone with a sense of pride.